What's up guys, I am here to explain LeetCode question number 1318, minimum flips to make A or B equal to C. So in this question we have been given A, B and C, and we have to make some changes into the bit representation of A and B so that A or B equals to C. For example, in the example number 1, A equals to 2, B 6 and C is 5. So let's just see how we can check the answer, right? So A is 2, great, B is 6, okay, and C is 5. These are the bit representations of 2, 6 and 5. Now initially, if we don't do any of the bit changes in A and B, what are we getting? Okay, if we do OR of A and B, we are getting 1 1 0, which is 6, but we don't want 6, we want 5, we want this, right? So how can we change this, right? Here as you can see we are getting 0, so we can just change this 0 to 1 and the OR will be 1 here. Here we can see that these are 1 and 1, but to make this as 0 we have to change both of these as 0, right? So 0 and 0, we got the 0, we got the 1 from here after changing the 0 to 1, but here it's same, so we don't need to do any changes. So the answer will be number of changes we did, it's 1 2 and 3, so answer will be 3. This is how we have to approach this question, right? But how can we check for this, right? What we can do is we can check bit by bit if A and B, if A or B for that bit is equal to C or not. If it's same, we will not move ahead with that, right? Let me explain you with another representation. Just a minute. Let's suppose A, right? Let's suppose this is A, it is 0 1 0, and this is B, B is 1 1 0, okay, great, and C is 1 0 1, okay. Now we will go from right to left bit by bit, okay. First we will check for these, right? Here as you can see, for these bits A or B is not equal to C, right? But if C is 1, we only want one bit to change here so that A or B becomes C, right? Because it's asking for the minimum number of flips, right? So we want to have the minimum number of flips to get C. So here we'll just swap one bit for either A or B, right? So if A or B is not equal to C and that bit in C is same, we will just change one bit, so we'll increment our count by 1. Here in this case the corresponding bit in C is 0, which means that both bits in A and B must be 0. But here it's not the case. We will check whether one of them is 1 or both of them are 1. If both of them are 1, like in this case, we have to swap both of them, we have to make both of them as 0, so we will increment by 2. But if only one of them is 1, we will increment by 1, okay. So that's how it goes. But now here we see that A or B is already equal to C. See, A or B is already equal to C, right? So we will not do any change here. We don't need to do any swap here, right? So our answer will be 1 from here plus 2 from here, answer will be 3, okay. Now how can we do this iteration, right? Like one by one, how can we do this? Okay, so first we need to understand one small concept in bits, okay. For example, if we have this bit representation, okay, 1 0 1 1 0 0 1, okay, we have this bit representation. If we want to access this bit, what we do is, let's say this is n, right? and if you want to access this bit, so what we will do is and operator then 1. Okay, so what we are doing is we are putting and between this and this one. Okay, right, all these are 0 here in the case of 1, right? So the and will be 1 and 1, it will be 1. If it's already 0, the answer will be 0. Okay. But if we want to access this bit, right, so what we have to do, we have to eliminate this bit first. So how can we eliminate this bit? We have to divide this number by 2. Yes, so if we divide it by 2, the bit representation will look like this, and then we can just access this bit, right, by doing n and 1, right? So this is what we are going to do, right, for both the numbers. I'll tell you, like if we have this number and this is A, this is B, 0 1 1 0 1, and this is C, right, like 1 0 1. Okay, what we will do is we will just first check for this, and then we will just divide by 2. We will divide all the numbers by 2, and we will get this number, and then check for this, and then again divide all 3 numbers by 2, and then we'll check for this, and then divide again, we'll check for this, right? If there is no number here, it means that it's 0, right? We will check for these, then again divide by 2, then check for these, and then again divide by 2 until we convert all the numbers to 0. We will count for all of the numbers. So let's just implement this really fast. Let's begin. So this will be our answer. Okay, while A or B or C. What does this mean? Okay, this means that while at least one of these numbers are non-zero, at least one of these numbers have 1 bit at the end, right? At least one of these has at least 1 bit in the end. What we'll do is we'll just check for the bit, right? This will be C bit. Let me clarify it for you. Okay, this is more clear, I guess. So let's see how it goes. So here what we are going to do is let's get some random example. This is A, this is B, 0 0 1 0 1. Okay, this is B, and this is C. Okay, this is C. Okay, let's begin with this example. This is A, B and C. Now here as we can see, what will be the C bit, right? This will be the C bit in this case, right? Because we haven't divided any of these numbers yet. So this will be the C bit. It's going to be C and 1. Okay, we are putting the AND operator here, right? So the answer will be here 0 and 1. It's going to be 0. Similarly for other bits, A bit and B bit. Okay, now we'll check if A or B is equal to C or not, which means that we have to check whether we need to do any of the changes at all or not. Let's say if A bit or B bit not equal to C. I think we have to decrease the font size a little bit. Yeah. Okay, this is how it goes. Now if these are not changed, which means that if we need to swap. Okay, now we have now there are many conditions here. If the bit in C is 0, which means that both of them must be 0. Okay, if C bit is 0, okay, and if both of the A bit and B bit are non-zero, we have to swap both of them. Okay, if A bit and B bit, we have to swap both of them, so we will increase our answer by 2. Else, now if only one condition remains, which is that either A or B is 1, not both of them together. So in that case, we'll just increment our answer by 1. Okay, now we have completed the case when the bit in C is 0, right? But what if it was 1? Okay, what if it was 1 here? So now we'll check if this was also 0, right? If this was also 0 and this one, we only need one of them to be changed, right? So we'll just increase our answer by 1 again. And then in the end, gotta divide all these numbers by 2. Okay, done. And then in the end, simply return the answer. Let's first dry run this approach, okay, for this example. First we are tackling this case here, okay. So if C bit equals to 0, no false here. So now it means that either this or this has to be 1, so answer will be increased only by 1. Okay, cool. Okay, now we also divided all these by 2, so this row will be removed. Now we'll check for this. Okay, A or B is equal to C. Okay, done. No need to swap. Next row. For this also same, no need to swap. Here we have to swap because it's not any 1 here, right? So what we need to do is we need to swap at least one of them, so our answer will be plus equal to 1, right? It will be this case. C bit is 1 and we have to just swap one of them, so answer will be answer plus equal to 1. Okay, done. Erase this also. Here I think both of these values are equal. Okay, these are equal, so no need to do anything here. Great. Same goes for here. A or B is 1 and C is 1, so let's see. Now in the end both of them became 0 and we'll just return the answer. Let's check our code if there is some silly mistake or not. Okay, so answer is coming 2 instead of 1. Okay, let's check. There must be some silly mistake. I know. Am I doing some mistake here? No. Oh, it's going to C bit. Okay, it will work run now. Let's submit this code, or let's just test for some insane numbers. Let's see. I'm sure it will run in this case also. Yeah, it ran. Time to submit and hope for the best. Yeah, it got accepted, fortunately, so that's great. So now time complexity here. What will be the time complexity? Time complexity is going to be the maximum value of the length of the bit representation of all these numbers. Okay, for example, if a is 8, right, so its representation will be 1 0 0 0, so the length will be 4, so the time complexity will be 4, right? So in this case the time complexity is going to be the maximum length of the bit representation out of all these numbers. So how to find that, right? So the time complexity will be log 2 plus 1, because if we are having 8, so the length will be log 2 8 plus 1, which is going to be 3 plus 1 4, right? So the time complexity is logarithmic, which is great. And space complexity is linear. We are not using any linear space here. So that's about it for the solution. I hope you like it. So thank you very much and see you in the next solution. Peace.